So we are going to see the just a second, let me do the setup. So basically we are going to see the design patterns, and I will let you know how it will be explained in this whole series. I will be creating a series based on the Kotlin design patterns, and design patterns represent a compendium of best practices and reliable solutions for frequently encountered software development challenges. So these are to overcome design challenges. So these patterns are collectively what makes you a seasoned or a proper experienced developer. Often provide solution for specific recurring issues in software design. Uh, they help in develop a developer's vocabulary to facilitate communication, collaboration, code maintenance. So your code will be more superior, more efficient, and maintainable code. So instead of facing the common problems that are faced by other peoples, we will be seeing how to overcome them using the design patterns. And uh, what is the language we are going to use? We are going to use the Kotlin over here. It is a versatile programming language that embraces multiple programming paradigm. It was created by JetBrains, and this is the same company that is involved in the development of Intel JID. So primary goal of this series is to introduce you to classic design patterns, whether you are unfamiliar with them or entirely or seeking to implement them in Kotlin. And after using them with other languages, Kotlin is a contemporary language naturally integrates many essential design patterns with their own syntax and core libraries. After eliminating the need to implement these patterns manually, nothing less recognizing the design pattern embodies by specific language further remains valuable. This updated edition focuses on the advancement in Kotlin up to Kotlin 2.2. With the ongoing evolution of the Kotlin ecosystem, this edition highlights some of the most thrilling features such as context receivers and significant libraries like Arrow. Okay, um, justifying the need of this series. So, what this series will cover? Let's say section one. Section wise, section will be just intro to Kotlin that we are going to see on the D1 or maybe multiple days based on that. Then we will have section 2 dedicated to creational patterns. These patterns focuses on how and when to create objects, how and when to create objects. Understanding that you will be able to manage your objects more efficiently, adapt well to changes, and write more maintainable code. Various patterns such as singleton and builder. Okay, then we will have section 3. To section 3, that will be structural patterns. Structural patterns introduce classic structural design patterns that can be used to extend functionality of objects and adapt them to changes. Extend the functionality of object. Extend functionality of objects. Okay, so first one deals with the when and how to create the object. Second one deals with the extend functionality of the object. Okay. And adapt objects to changes. If some changes happen, how it will affect the object, it deals with that. Then we have section 4, that is creational pattern is done, structural pattern is done, then there is a behavior pattern. So basically this pattern, it focuses on the how objects interact with each other, how objects interact with each other. Okay, you will learn how an object can exhibit different behavior depending upon the situation, how object can communicate with direct knowledge of one another. It basically deals with the communication between two object 1, there is object 2. Between this there should be some communication, and this pattern, the behavioral pattern, deals with this, the communication between two objects. Then we are going to see functional programming. Functional programming is what? We are going to see the fundamental principle of functional programming and their connection to Kotlin. Without dwelling much into new syntax, we will address key concepts like data immutability. Here we will see data immutability and function as first class citizens. When the principle was crucial for grasping Kotlin's advantage in the earlier sections, here we examine the significance within the functional programming instead of examining their applications in implementing design patterns. Our focus will be on their essential role in crafting code that is more concise, modular, and maintainable. And further moving on, section 6, we will see threads and coroutines. Uh, they are used to manage the multitude of requests in our application. Threads are traditionally the go-to for their use for the concurrency in contemporary applications. However, Kotlin offers coroutine as a software. More threads are generally used for the concurrency, but Kotlin uses coroutines that for the concurrency that is more efficient, as it is more efficient than your traditional threads. We will see what are the advantages when you say the coroutines are more efficient than thread. It should be justifiable. Okay. We will demonstrate the implementation for processing a high rate of requests. Furthermore, we will explore structured concurrency in Kotlin, a feature that enhances the safety and efficiency of concur. Of this concept will be provided along with insight into its application for boosting the performance of our application. It is for performance boosting of your code. Then further on we will see section 7. We are going to see the controlling the data flow. Control of data flow. Here we will see how the higher order function that can be used with collections and concurrent data structure. Higher order function to be used with collection and data structure. Then in section 8 we will design for concurrency. Explores the widely utilized concurrent design patterns, particularly those implemented using coroutines. Okay, we'll see design patterns implemented using coroutines. These patterns enable the simultaneous manages of multiple tasks. We will handle multiple tasks over here, and we will also discuss how coroutines synchronize their execution to our trace condition. How to sync to eliminate race condition. This is done. Then we will move to further section, that is section 9, that is idioms and anti-patterns. So here we will discuss the optimal and less optimal practices in coding in Kotlin. We'll go over what the preferred coding style for Kotlin is and identify certain coding patterns. Certain coding patterns will be seen over here, and we will go what the preferred coding style for Kotlin is, and identify certain coding patterns that are not recommended. What not to do will be seen here. What to do, what not to do. Once you have completed this chapter, you should be able to produce Kotlin code that is easier to read and maintain, as well as steered clear of typical coding mistakes. Okay, right. Then we will move to section 10, that is practical functional programming with arrow. Functional programming with arrow. Arrow is what? Uh, we will use the knowledge of functional programming and coroutines from the previous parts and put them into action using arrow framework. Arrow is a framework. Arrow aims to provide a uniform and idiomatic functional programming experience for Kotlin developers, making it accessible to all. We will explore the power of Arrow in writing concise, expressive, and maintainable code. Through this chapter, we will highlight the key feature and benefit of the Arrow framework, showcasing how it enhances development and uh, enables the adoption of functional programming principles in Kotlin. With Arrow, developers can unlock the full potential of functional programming while capitalizing on the flexibility and robustness of the Kotlin. Then we will move on further. In section 11, we will deal with the concurrent microservices, and we will use the ktor to handle the concurrent microservices. So whatever we have learned previously, all this we will be using over here, concurrent microservices using ktor, and we will build a microservice. We will build a microservice using Kotlin, and we will use the ktor framework that is also developed by the JetBrains. By following the example, we will be able to create your own microservice using Kotlin and ktor. Then we have section 12. This is last section where we will be dealing with the reactive microservice with vertex. So we can create a concurrent microservice and we can create a reactive microservice. So for concurrent we will be using ktor, for reactive we will be using vertex framework. So vertex is based on reactive design pattern. We will examine the advantage and disadvantage of each, approve and analyze real code examples to determine which to use when, and yeah, we will be seeing certain examples and we will have some assignments over here to complete. Okay, so this is the introduction for design patterns with Kotlin. section 1. Classic patterns. So our first section we will focus on introducing the fundamental syntax of Kotlin. I will show you. We'll focus on the syntax and explore the applications of traditional design pattern within Kotlin. Traditional design patterns addresses three primary challenges in design, system design. Okay, there are three challenges. Uh, First is efficient object creation. Your object should be efficiently created. Then there is effective encapsulation of object hierarchy, and third is dynamism in object behavior. So we will explore the design patterns that are inherently part of Kotlin and provide guidance on implementing those that are not. So first of all we will get started with the Kotlin. Then this further efficient solution, how to efficiently create the objects, how to efficiently encapsulate the object hierarchy, and dynamism in object behavior we will be seeing in the section 2, 3 and 4. So by the end of this section you will have a solid understanding in Kotlin basics and know how to implement all the classic design patterns in Kotlin. So let's get started with the Kotlin. First section will primarily focus on the fundamentals of Kotlin syntax. It is crucial to have a strong understanding of the language before diving into the implementation of design patterns. You should know the language before design something. Before design, you should know something before designing something. So we will also briefly explore the problem that design patterns aim to solve and explain why they should be used in Kotlin. This will be beneficial for those who are less familiar with the concept of design patterns, and eventually even an experienced engineer can gain interesting insight from the discussion. So it's important to note that the chapter doesn't aim to cover entire range of the language vocabulary. Instead, its purpose is to introduce you to fundamental concepts and idioms. In the later section, we will gradually introduce more language features as this become relevant to the design patterns we examine. So further on, we will go step by step to understand what are the Kotlin behaviors or usage of that. So yeah, let's move on further slow and steadily. So if you have gone through Java, C Sharp or Scala or other similar programming language, you will find Kotlin very quite similar syntax one. Uh, this is by design, as Kotlin aims to facilitate a smooth transition from those with experience in other languages beyond solving real world problems with features like improved type safety. Kotlin also addresses shortcoming inherent in other languages such as Java's notorious null pointer exception is there. Java has a major issue, that is null pointer exception, and absence of top level programming function. Top level function, not top level programming, top level functional programming. The language maintains a practical approach that is consistently applied throughout its design. One of the major advantages in Kotlin is its ability to work seamlessly with Java. You can use both Java and Kotlin classes together in the same project and freely use any Java library. However, it's worth noting that the interoperability isn't without its challenges, such as dealing with nullable types. So, while integrating it's robust, some effort is required to address the nuisance. Uh, so, what does the Kotlin tries to achieve? Okay, so what Kotlin tries to achieve? Yeah, okay. This should be something that Kotlin wants. First is pragmatic, that is simplify. Simplify the common tasks. Your code should be readable and easy to use. It should be also safe, and it should be interoperable. Whatever the existing libraries of Java or uh, there are Spring frameworks, Hibernate, and JOQ, multiple things that should be used along with the Kotlin as well. So yeah. So what are the paradigm? Multi-paradigm language. Kotlin is multi-paradigm. Multi-paradigm means there are multiple paradigms, like procedural is one, object oriented is one, and functional. So all the features are included somehow in Kotlin. Uh, it is simple. We try to achieve pragmatic behavior. So Kotlin is pragmatic, simple, and accommodates all these paradigms. You are not forced to adhere to a single paradigm as other languages do. Kotlin incorporates classes and inheritance from the object oriented. From the object oriented, we have the feature of uh, incorporating classes and inheritance. Also embraces higher order function from functional programming. However, Kotlin does not improve the necessity of encapsulation everything within the classes. There is not a necessity to encapsulate everything within classes. Okay, unlike Java. So if you desire, you can structure your code purely as a collection of procedures and structs. So uh, throughout the examples, we will see how to achieve these different paradigms to solve the problems. So instead of providing comprehensive coverage of each topic, uh, we will gradually build the knowledge step by step. So Yeah, when you start programming in Kotlin, the first step is to create a new file, which will generally have a .kt uh, extension. So, just for example, I'm showing you there will be a code. You'll create a file. It will have .kt extension. You will write some code. You will run this code. Okay. So before this .kt extension, there should be some name, right? Let's say apple.kt. But Kotlin doesn't restrict enforce on one-to-one relationship between the file name and the class name. Let's say you can have the class named banana over here, though I don't recommend to use a different name for the file and the class that is used inside it, but you can do that in Kotlin. It is not strictly enforced. While you have the flexibility to include multiple public classes within a single Kotlin file, you can have banana or cherry or fig, anything. Multiple classes you can have within this file. These are classes, okay? Don't get confused. Classes. But it is practically more logical to uh, group together the related classes in a single file. Uh, don't do like this. Okay, you can use a fruit.kt and include this. Maybe I'm not sure how of them, what of them are fruit or vegetable. Okay, but it will be little difficult to search as with the classes are there. You can have other things. Unlike Java, you cannot see this is the class name, this is the file name, and these are the classes that will be included in this file. So you should follow some naming conventions also there. Uh, as a convention, if your file consists of a single class, it is recommended to name your file the same name as your class. Whatever the name of the class is, then use the same name in your file as also. When your file contains multiple classes, the file name should describe the shared purpose. If you have multiple classes, shared purpose name should be given, or the theme of those classes. uh, and it is always uh, recommended that you use upper camel case while naming your files, right? Upper camel cases. So it should have been apple.kt, not small e. This is upper camel case. Then we will see packages in Kotlin. Just let me get a little bit of water. Now we will see packages. What are packages? So packages in Kotlin is a collection of files. Of files and classes that share common purpose or domain. common, as per their common purpose, we will group them together, we will collect them together, and they'll be kept under organize your classes and function under a unified namespace, often residing in the same folder. So this concept is prevalent in Kotlin as well as many other programming language. To declare the package that a file belongs to, use the package keyword. We will use something like this. Where is this? We should go. We change the color. Oh, I can do one more thing. You go to your previous color. Okay, this can be green. You should be green, right? I like this color, man. Go to green. Okay, and package should be described like this. You have to use the package keyword, then use something like com dot example dot fun. This is syntax for package. Looks awesome, man. Okay, so when working with the mix of Java and Kotlin files, it is important to ensure that Kotlin files adhere to the Java package naming rules, which are specified on the naming package somewhere. So Kotlin provides flexibility in organizing packages within directory and files. It is highly recommended to align with Java's packaging naming rules for consistency and interoperability. Additionally, many IDEs will display warnings or suggestion to place a file in the correct directory according to the package declaration. This feature can be particularly helpful in maintaining proper organizations when working with Kotlin and Java files together. In purely Kotlin projects, it is permissible to omit common package prefix from the folder structure. For instance, if all your Kotlin projects reside under this com.example.fun package and a specific part of your application deals with mortgages, you can directly place your files in the mortgage folder without following the nested structure as required in Java. So instead of doing it like that, com example function, and let me name it something. Let's create it as Valorant, and here you will create main.kt. Instead of like doing that, you can do Valorant and main.kt. You can maintain like this also. In the main.kt, there is no need to explicitly declare a package over here. Then coming to the comments, you can have single line comments like using this, multi-line comment using the syntax. So much like other programming languages, we have the comments in Kotlin. Use commands to describe your code. first code. uh, Open the IntelliJ IDEA. That it opens smoothly. No need to worry about anything. Okay, let's create a new project. What we use? Okay, so this is main.kitty. Remove all the shit. We just want to print. Let it take some time. It will take a little bit of time. It is done. We can run the code. This triangular button over here. .qt. .qt is not loading. How is it possible? Let me see. Yeah, it is still building. Wait. run our code. So much struggle for such small thing, man. Damn. Here runs our code. Code. Yep. Here you see hello Kotlin is output. So there are some notable difference in this code compared to the equivalent Java code. Let me open something else so I can explain properly. Online GDB. Yeah, it will be a little bit easy over here to show the code. With the hell on this Java. Yeah. Let me run it. So here can you see the Java code and Kotlin code is totally different. Uh, so we will use the online GDB more compared to other things. So in languages like Java, C Sharp, Scala and many others, it is mandatory to encapsulate every function within a class for it to be executable. Okay, but Kotlin introduced the concept of package level functions. If a function does not require access to a class property, there is no need to wrap it within a class. So if there is no need of a class, don't use it. No need of class, don't use it. Okay, no need of wrapping class should be there. If you don't need the class, use the package level functions in your code. There is no need to wrap your code inside the class. It is defined directly at the package level. It is as straightforward as that. So package level functions. अरे भाई मत आना. Command line applications. No need of static modifier over here. You can write it like in some languages the static keyword is used to indicate functions within a class that can be called without creating an instance of the class. The main function is a classic example of such usage. In contrast, Kotlin gives you more flexibility. If a function doesn't rely on any internal state or class properties, you can define it outside of any class. Kotlin doesn't use static keyword for functions, and this has been the case from Kotlin 1.2 to current Kotlin version. It is worth mentioning that while this approach enhances modularity and code reusability, there is also a downside. For example, when a function is separated from its logically related class, it might be harder to follow the code structure and maintain encapsulation. Less verbose print function. Rather than using the verbose system.out.println method in Java, which prints a string to the standard output, Kotlin offers a conventional alias println. This alias function static is identical to that of system.out.println, allows you to output strings to standard output in a concise manner. It is important to note that println is an inline function, which means it gets replaced by its contents in the general code. This inline behavior makes it clear why we refer to it as an alias, and there is no need to use semicolons also here. No semicolon. In languages like Java and many others, every statement or expression must terminate with a semicolon. For instance, you write something like this in Java. This is Java expression. Our Kotlin takes a pragmatic approach. It automatically infers during compilation where semicolon should be placed, sparing you the need to explicitly include them. For instance, like I'll just show you how you can write it in Kotlin. This is for Kotlin. In Kotlin, most of the times you won't need to use the semicolons in your code as they are considered optional, aligning with Kotlin's emphasis of pragmatism and consciousness. This flexibility eliminates unnecessary clutter, allowing you to focus on essential aspects of your code, which contributes to its readability and maintainability. However, like many conveniences, there can be some downsides to this flexibility, which, while it makes coding easier, especially for experienced developers, it is essential to consider readability for yourself and others who make work on your code. While Kotlin's flexibility allows for concise code, it it's crucial to adhere to best practices and coding standards. For instance, even though semicolons are optional, using them in specific situations can enhance code's readability, particularly when separating multiple statements on a single line or in enum declarations. So ultimately, Kotlin provides flexibility to write code efficiently, but it's important to balance this with writing code that is clear and understandable, uh, following your industry's best practices. Then you have to understand the types. Mm, Kotlin is a safe type language. Now let's see what is this type system and compare it with what Java has to offer. First of all, we have Basic types. Uh, in some languages, a distinction is made between primitive types and objects. Java, for instance, has the int type for primitive values and integer for object. Java uses this int for primitive and this integer for object. This is the case of Java. From a developer's perspective, all types in Kotlin are treated equally, and you typically do not deal with the primitives directly. Okay, which is a significant departure from Java. In Java, you often need to consider how, whether you are working with primitives or objects when writing code. So, nonetheless, this difference does not imply that Kotlin is less efficient than Java in this regards. The Kotlin compiler optimizes types behind the scene and ensure the performance is not compromised. Therefore, you may not be dealing, you not directly deal with the primitives in Kotlin. There is no need to be overly concerned about it from the efficient perspective. Most of the Kotlin types have similar names to their Java counterparts. The exceptional include Kotlin's int, where the Java's integer is used, and Kotlin's unit replaces the Java's void. Now, further on, moving further, we will see the type interference. Let's see. Inference, sorry. Type inference. So, let us declare our first Kotlin variable by extracting the string from our hello Kotlin example. What was it? We had not used a Kotlin variable, so let's use a Kotlin variable. I have to move it to Kotlin. So it should show hello Kotlin. That's pretty fast compared to that. Oh, it doesn't support the debug mode for Kotlin. Fine, no need to worry about anything. So it's important to note that nowhere in our code do we explicitly states that greeting is of type string. We have not said that what is the type for this greeting. Instead, the compiler determines the variable's type. Unlike interpreted languages such as JavaScript, uh, Python or Ruby, the type of variable in Kotlin is inferred only once during the compilation. Only once during the compilation, it is inferred. Kotlin compiler infers the most specific type of the variable, so in this case it infers the greeting to type string only once, unlike JavaScript and Python, not any. Okay, so however, if you try to assign it to some other different value, let's say let's assign it to some integer, and I already told it will be inferred only once. So if you try to change it, it will say okay, you are trying to change the type of this particular value, so it will lead to the issue. If you prefer to explicitly define the variable type, you can use the following. If you want to specify the type, you can say specify it like this. So greeting is of type string. So by explicitly specifying the type as string, the compiler will enforce type compatibility and raise an error if the incompatibility value is assigned to the variable. However, it's important to note that Kotlin will raise a compilation error if you try to assign the wrong type, regardless of whether you explicitly specify the type or rely on type interference. So in real world scenarios, explicitly defining the type can be beneficial when you want to provide additional clarity to your code or ensure compatibility with other parts of your program. For example, when working with complex expressions or in situations where type inference might not produce the desired result, specifying the type explicitly can make your code more understandable and help prevent potential issues. Then values. Only once. Let me stick this. So in Java, variables can be declared as final. You can declare the variables as Java में variables can be final. So final variables can be only assigned once, and the reference is effectively immutable. If you try to reference that value, it will be immutable. Something like this: final string name equals to, your name should be always once assigned, and if you try to say name equals to shark, this will not work, or it will lead to the error, as this is a final, due to which it will cause the issue. Kotlin promotes the use of the immutable data whenever possible by providing developers with a clear distinction between mutable and immutable variables. So Kotlin has something mutable and immutable variable. So we'll take the break for 15 minutes, then we will further proceed.